what I wanted to talk about today are these things. These are obviously USB car adapters that you plug into the car lighter socket to get USB out, power out. This is a rather old one. The copyright notice on there is 2013. And this one only produces, if I remember right, 1 amp at 5 volts. So it's useful, but not so useful. This is a later one. This one produces 2.1 amps, so that is potentially a little bit more useful. And this is one I recently bought because I wanted a USB-C charger. My car already has at least 1 amp, 1.5 amp, I think, off of regular old USB. But a USB-C charger, this one gives you 30 watts, which makes it useful for charging an iPad or even a Mac in relatively reasonable time while you're driving around, which struck me as potentially useful for camping or something like that, but also a good backup power source. You can even get 100-watt rated ones, although how realistic those are, I don't know. You can pull a fair amount of power through the lighter port because it was designed to run a lighter, which would draw, 150 watts or so, whatever cigarette lighter when it was heating up. So put these aside. This one is obviously still useful. This one is less so, but since it's got a 2 amp output, I'm inclined to keep it. This one is surplus to needs, and I'm going to try to get into it because I'm curious as to what's inside here. This one I can tell from the box, which you absolutely will not be able to read, but maybe you will. But if you look at the total power output and look at USB-C, it produces 5 volts at 3 amps, 9 volts at 3 amps, 12 volts at 2.5 amps, 15 volts at 2 amps, and 20 volts at 1.5 amps, and there's 30 watts max. The important thing to note about this is that a 12 volt input supply is really going to be 12 to 16 volts realistically in a car, 12 to 14 volts, but is well below the 20 volt. So this one has to have a buck boost converter in it to raise the power up to the 20 volts required for its 30 watt power supply. This, I don't know, this could simply have a linear regulator in it, as could this. So I'm curious to see what's inside it. It appears to have a single welded seam. I don't have a lot of tools here, so off camera I'm going to probably hit this with something and then just see if I can cram a knife or something in there and try to get it opened up. I don't mind if I bust this because it's never going to get used again. All right, back in a minute. So that turned out to be quite easy to open up, and let's see what we've got inside it. It was glued together along here, and I just busted it open, as one does. We have a chip. Let's see, I'm going to try zooming in on that. I can't read it right now. You guys might be able to read that better than me, but I will see if I can read that. We've got some resistors, a few capacitors, and we've got a coil. So this is and an output smoothing capacitor. So this is a buck power supply, not a buck boost, because it's going down to 5 volts, but this is a regulated power supply running off the 12 volt input, which is coming here. What's interesting about this, and makes it very different from a lot of older 12 volt stuff that you see, is there's often a fuse hiding under the end cap here, and I see no fuse unless, well, it looks like a capacitor to me, but unless there's a polyfuse or something on here, which you might expect. There's the LED, right? So, at least in this Duracell branded one, It's a proper regulated power supply like you might expect inside a cheap USB power supply. So really, there's nothing wrong with this. I'll throw it out probably. Maybe I'll try to see if I can get that chip number off. So I was able to find a data sheet that looks like it's for this little chip. The chip is a CXW8508. This is for CX8508. I'm not sure what the difference is, but this doesn't seem to be this. This is a synchronous buck regulator with an operating input voltage from 4.75 to 25 volts, so that's perfect for something like this. This claims its input voltage is 12 volts to 24 volts. They might be pushing this, but maybe the W version goes a little farther. It's got an adjustable output, and we can see what the pins are. We have the application circuit, the example, and here we have a 10 microhenry coil, which is presumably what we're seeing on the back. We've got a resistor one, and we have, I'm not seeing a capacitor across the output here. I must be output. Anyway, there must be a capacitor across the output, at least in this, but I don't see it. Here's the ground. They've got a ceramic capacitor. That's probably designed to filter, but yeah, I'm not seeing a large smoothing capacitor on it, but whatever. That's what it is. Oh, we've got the functional description of it. And yeah, how you calculate the resistance values and diode selections for use with it. So very straightforward. It's just, I mean, you don't need to, try to build a schematic from this. What I just find very odd is that there isn't any fuse on it, and that I find a bit disturbing unless they're expecting one of these resistors to effectively act like a fuse. Okay, hope that was useful. Thanks for watching.